In this lesson, we'll review a solution to our simulation test problem. Keep in mind that in nTopology, users can build their notebooks slightly differently to achieve the same results. For this problem, your workflow should look something like this. We'll begin by importing our CAD part, then pulling our body out of the properties in the block details. Then we'll identify our faces of interest, starting with this loaded face and our two restrained faces. Now that we've defined our geometry of interest, we can move forward to creating our FE model. We'll begin with a mesh from CAD body to triangulate the surface of this CAD body. Then we'll use a remesh surface block to generate a more uniform mesh. Note that for our edge length, we created a variable with that 3 millimeters so that we can keep it consistent with our FE mesh later in our workflow. After remeshing the surface, we can use this volume mesh block so that our initial surface mesh with no mesh infill is now meshed all the way through. We'll then use an FE volume mesh block to convert it to an FE mesh. And then we can move on to creating our FE model. We'll use our bracket mesh as our mesh in our FE component and add an attribute list and a solid attribute block. For our material, we've created a material variable of aluminum 6061. Note that we didn't add any connectors as we're only working with this single body. After establishing our FE model, we can move on to creating our boundary conditions. First, we'll apply a bearing force to this lower face using the FE face boundary block and our loaded face variable that we created in our geometry section. We'll apply a force vector of -2 newtons along the y-axis to reflect the 2 Newton bearing force downwards in the y direction that we see in our prompt. Next, we'll create our displacement restraint along these restrained faces in the top corners of our bracket. And again, we'll use this FE face boundary toolkit block. We'll leave all inputs in this displacement restraint as 0 so that these faces are fixed. Now that we've created our two boundary conditions, we can move on to running our static analysis using our static analysis block that can be found in the Design Analysis tab or our Simulation tab. If I isolate the static analysis using I can review the static analysis results in this heads-up display. I'll use the deformation scale to help visualize how our part would deform under this loading. I can control my color palette and transition using this settings widget, and I can probe values using our probe mode. To view simulation results inside the FE model, I can section cut using the hotkey X. Select Show Volume Mesh Elements, and probe over individual mesh elements. In addition to displacement, I can look at the strain, stress, and reaction forces of our loaded bracket. Hopefully you achieve the same results, and feel free to download the solution file below as reference.